Welcome to Chapter 2 of our Flat Earth series. If you have not seen Chapter 1, NASA, I recommend you check that out first before diving into the topic of gravity. Gravity is the glue of the heliocentric world. Without it, everything crumbles at first sight. Let's look into first what gravity is taught to be, and then let's test that out for ourselves and review some independent research. Disclaimer: if you are fixed in your reality with no curiosity of re-examination, please turn this video off. You will be triggered. This is for the curious mind capable of open examination. The definition of gravity. Gravity is defined as the invisible force that pulls objects with mass toward each other, keeping planets in orbit around the sun and making things fall to Earth. It is described by Einstein's general relativity as the curvature of space-time caused by mass and energy. Let's take a deeper look into Einstein's theory. The theory attempts to show how massive objects warp space-time, affecting the motion of other objects and the passage of time. The crux of this theory is dark matter. In general relativity, you can predict galaxy cluster motions from the visible mass. Mass is the amount of matter present in an object. However, if you plug only the visible mass into Einstein's gravitational equation, you get the wrong speeds. The measured speeds are too high, meaning either we're missing mass, like dark matter, or gravity behaves differently than general relativity alone predicts. So people suspect missing mass, and they think up the idea. Dark matter, extra non-luminous matter, whose gravity makes up the difference of the calculations that do not match up to the actual measured speeds. Are you feeling confused yet? There's a reason why. It's because truth is simple and lies are complicated and convoluted. The scapegoat that is dark matter has never been proven, recorded, or demonstrated in any way. There is no factual evidence of its existence. It literally is a concept conceived to explain the reason for gravitational calculations not adding up. Not surprisingly, Einstein's general relativity is a theory. It is not proven, only theorized, hence the theory of general relativity. This is all to prop up the concept and idea of gravity, because without this concept of gravity, we would have no explanation as to why everything isn't flipping off of this spinning globe. All the waters, all the people, all the buildings, everything. Because, right, it's spinning super fast through the universe. Anyways, we'll get more into that in the following chapter. Still skeptical, either because perhaps I'm a woman and not a scientist? Fair enough. Let's hear what Nikola Tesla had to say about this himself. And I quote, "Einstein's relativity work is a magnificent mathematical garb. It fascinates and dazzles. This makes people blind to the underlying errors. The theory is like a beggar clothed in purple, whom ignorant people take for a king." On the curvature of space, a key element of general relativity, I quote, "I hold that space cannot be curved. This is for the simple reason that it can have no properties. It might as well be said that God has properties. He has not, but only attributes, and these are of our own making. Of properties we can only speak when dealing with matter filling the space. In the presence of large bodies, it is said that space becomes curved. This statement implies that something can act upon nothing. I, for one, refuse to subscribe to such a view. Take a minute to take that in. That's profound. Tesla also rejected aspects like mass increasing with velocity and the speed of light as an absolute limit. I agree with this. The speed of light is not an absolute limit. Density. So, if gravity doesn't exist, what are people mistaking gravity for? Density of objects. A feather will fall at a slower rate than a tennis ball. Objects are being pushed down from above, not pulled from below. As mainstream science claims, gravity is a force that pulls objects towards the center of the earth. Objects fall or rise based on their relative density to the medium surrounding them. Oranges fall because they are denser than air, while helium balloons rise because they are lighter than air. There is no gravity in that equation. Air rises in water, water falls in air, because water is denser than air. There is an interesting occurrence called density equilibrium, when objects levitate, when the mass and volume of a balloon plus the gases inside equals atmosphere air density outside. Buoyant force is the opposite of density. Buoyant force is the upward force a fluid exerts on an object that is fully or partially submerged in it, caused by the difference in pressure at the top and bottom of the object. Submarines float and sink according to water markers, controlling the amount of air-to-water ratio let into the sides of the submarine. There is no gravity in that entire equation. The gravimeter. Gravimetry is the measurement of the strength of a gravitational field. It determines the rate at which things fall. Let's examine the calculations used for measurement.
Where the height is 1/2 the acceleration times the time squared plus dt. So we got to remove this term over here. We're going to simplify it and say the velocity is 0. So we're just going to do the rate at which things fall downward. So we're going to be dealing with the height and the time. So then we simplify it, algebraically shuffle it around, solve for A. We end up with A equals 2 times the height over the time it takes to fall squared. And that is all we're measuring with our gravimeters. This is all what gravimetry is based on, is the deviation in this tiny measurement. A equals 2 times the height over the time it takes to fall squared. So again, here's this, why it doesn't appear, there's no big G in here, because this is just kinematics. This is just motion. This is just an observation of the rate at which things fall. We're doing nothing for the cause for why things fall, just observing and measuring and calculating the rate. Now, I think globe proponents on Twitter and people who probably don't know the inner details of this would argue that you can't have this without this. However, there's actually no link between this and this, as we're showing. The logical link comes afterwards when you physically solve for this, then you insert it into this to make this equation work. And this is built on this already equaling 9.8, right? So this is the only one where you can solve for locally and will give you the correct answer every time, assuming your variables are correct, right? So this is what they're saying causes it, but this is independent of this. So this shouldn't be independent if this is the cause. That's the argument.
We only need to know the height at which an object is dropped and the time it took to hit the ground to calculate the rate at which it falls. The method and formula used does not calculate gravity into the equation for the gravimeter.
Put it in a real world example. I'd like to use this example over here, and the only 2 parameters you need are here. The height it's dropped from, this is our h, and the time it takes to fall is going to be our t squared in the equation. Right, so if you drop something from 10 meters and it takes 1.43 seconds to fall, you can quickly solve, plug that in, 2 times 10 over 1.43 squared equals 20 over 2.0449, which when factored out, of course, 9.78 meters per second. There's a couple other examples you can work through, but the result's always the same. No big G, no cause for the downward acceleration ever inserted here.
In conclusion, how is it that gravity is so strong that it can hold all the oceans and people on the underside of the spinning globe, but so weak that it allows birds and balloons to evade its force? The true constant is density and buoyancy, not gravity. This is just another part of Freemasonic pseudoscience. These insights and alternative perspective can begin to cause cognitive dissonance. I'm fully aware of that. I encourage you to take time to breathe and slowly process this information. Many people's sense of reality starts crumbling once we begin to illuminate the illusions of the matrix. For the next chapter, I will be going into video proofs, testing things out in the real world. This is where things are going to get very interesting. I will see you in the next chapter.
Earth bulges. We are about 5 miles wider across the equator than we are pole to pole.
Okay.
Not only that, a slight detail, we are wider just below the equator than at the equator. So since we're squashed pole to pole, that makes us oblate.
Okay.
And we're not a perfect sphere. It's a spheroid. It's an oblate spheroid.
Okay.
Oblate
And we're
spheroid.
slightly wider below the equator, so we're a pear-shaped oblate spheroid. If the Earth bulges from spinning, if you bulge at the equator, the poles come in a little bit.
Down, right.
Okay? So now it sounds like I'm closer to the center of the Earth, I should weigh more. However, not the entire Earth is pulling on you. It turns out that while you are closer to the center of the Earth, there's less mass pulling on you. You can show this with calculus and Newton's laws of gravity, that if you are smaller from pole to pole, the only part of Earth attracting you is the sphere that is the cutaway between your feet and the center of the Earth. And that sphere does not include the bulging that comes outside of that sphere.
Okay.
Those factors combined exactly equal the factors that affect your weight here on the equator, because the entire mass of the Earth is pulling
on you because you're at the center.
Okay, because you're at a widest point.
Right.
What is the sphere beneath your feet? It's got everything.
It's all of it.
All of it.
It's all of it. So these two things, these two, principles, if you want to call them, they cancel out.
Yes, they exactly cancel. The fact that you have the whole Earth pulling on you, yet we're spinning.
Right.
Okay? So you have all the mass of the Earth, but the spinning, so that makes you weigh more, but then you're spinning, that makes you weigh a little less, plus the Earth is a little wider, so that makes you weigh a little less. Okay? All of that,
You put it together.
it comes out in the wash compared to your weight on the pole.
Wow.